just brief introduction of me. I'm Lino Telera, and I'm a platform engineer, and I'm also a HashiCorp ambassador. And I simply put my experience here with my employee, and also with the experience that I got with many, studies or laboratory that I'm doing at home. So so you can find here on my social network where you can reach me and stay in contact. So the agenda for today is pretty tight because in 30 minutes I try to give you some explanation or some insight about platform secret management, how to do well the secret management in your platform using obviously HashiCorp Cloud Platform, and also we introduced some concepts like the cloud sandbox with authentication and the authorization. Then we'll dive into how to share Vault secret in Terraform and how you can bootstrap your workspace using OIDC role and policy. And so, obviously, we have a time for a demo because we want to see this thing in practice. All right. As a platform engineer, I'm working every day with the security. And because I'm working in a digital trust company, security is in our DNA. And platform security is so important. So we using this kind of tool to address multi-cloud complexities like HashiCorp Cloud Platform. We know how to centralize the code management and do some multi-cloud integration. And for sure, the integration with the other tools like Packer, Vagrant, Boundary, and Consul will give you another, a great platform to do this. But the thing is that we must handle the security and also implement the zero trust. That is not an easy way, especially in a brownfield. So I will give you some hints on how to address this. So we know that in order to authenticate with the platform, we can use a client ID and secret, which is the easiest and the simple way to start using your cloud provider, your cloud as target of your deployment. But the number of the keys will increase a lot, especially when you deliver your application in a multi-account or in a multi-cloud, And things are not changing, especially when you are integrating with your automation tools. And I think that also with HashiCorp Cloud Platform, we should find a way to better address these keys around our automation. In another side, we find that also the secret lifecycle management in our infrastructure as code is still challenging because we are not dealing with the secret for example, in a vault. But sometimes secrets are generated during our infrastructure deployment. As we've seen, for example, for a DB, EC2 instance, Kubernetes clusters, and so on. And we must use those secrets to deliver our application, because our application, in some way, is consuming, is using those secrets and consuming the resources based on the access they have. And here is the problem. How many times you've seen where to put our API keys and your secret? And believe me, Git is not forgetting. Anyway, so let's introduce how to handle secret in a platform. So handling secret in a platform means keeping a safe place, but also make this secret available where it needs. And finally, because we are respecting the zero trust, we must manage and rotating. And so we are seeing with zero trust a kind of abstraction of the world secret management, like handling secret in a different flow. using or avoiding the password that are not clear, that must be handled by the elements that we deliver without compromising the security. And the most important thing for the Zero Trust is we must extend the secret management across any cloud and any platform. So the first step, for sure, is to solve the problem to integrate our HashiCorp Cloud platform with your cloud. And we have seen that, okay, using API is key, and just keep those API key in a secret place could be a starting point. But we need to bring more secure way to do this. And so another idea is to place a remote agent and doing a remote computing instance that simply bring the IAM role to deliver your infrastructure. But finally, the better way is to implement the OpenID methodologies to dynamically handle secrets, but no more secrets. So handle things in a different way. So OpenID Connect simply connects, enables application developers to sign in and receive a verifiable assertion about users across other applications. In this case, we are using application, we are using the platform. So from one side, we have HashiCorp Cloud Platform. For the other side, we have, this is an example with AWS, but you can do with everything is implementing this methodology. And by using a federation between your client ID from your HashiCorp Cloud Platform and IAM role, for example, in AWS, you can implement also a policy attached to this IAM role. So we can solve two things in one step. One is the authentication, and the other is the authorization. So where to start? OpenID could sound a little bit complex, but there is an easy way to implement. So this is an example using a GitHub repo that is officially handled by HashiCorp. You can find the ways how to dynamically handle credential setup using Terraform. So you can start with your environment, and then by using this way, you can simply connect your workspace with a particular IAM role. And after the authentication, it's time to dive into the authorization. Here, there is another concept that I want to share with you, which is the Sandbox. Sandbox is, let me say, something where you can bind a workspace with a particular role, and you can find the boundaries where a particular team can deliver in your infrastructure. This is respecting the air gap between environments and application, but also guarantee the least is privileged and the separation of duties, which is, according with your organization, this is the best way, in my opinion, to handle the whole life cycle from infrastructure to application. And so this is an example implementing in HashiCorp Cloud Platform, starting from organization, then dive into a project and connect every single workspace with a particular sandbox, which is a simple definition of policies that are in AWS. So in this way, you can implement multiple roles, as we've seen, like infrastructure and applications. And then we are starting with handling also, because we are using HashiCorp Cloud Platform, multiple streams and multiple environments. And we are centralized all the templates and implement variables. But in order to really handle, centralize also the security, we must implement a key or ways to centralize the authentication methodologies and try to put a policy for every workflow. So it's time to see something in practice, and I prepare for you. You will find also this this link on the last at the end of the presentation, because I want to share with you some code, right? Because I have already tested, and also I prepare a model for you. So just do this first step that I call Bootstrap. So you are bootstrapping one or more workspaces, and then issuing Terraform login. So just do it once, a login in your HashiCorp Cloud platform, and once using a temporary access keys for the AWS, for example, you can starting delivering your workspace, which is already ready to deliver your infrastructure element. So it's time to see a demo. OK. So as you can see, we are starting with an empty workspace. We define also some basic secret that we are sharing during the other deployments. And the most important thing here is that we have only the basic role that is defined in a particular AWS account. Then, by using two providers like AWS and Terraform, we can implement the OpenID authentication using AWS IAM OpenID connection provider. Then time to do the same with the Terraform Cloud, and defining our organization and our project, we are now ready to deliver our first workspaces. So just let's take a look on variables. As I told before, the whole code is available on GitHub. And so we have a definition by using this module, because I prepared the model for you. So it's pretty straightforward to just git clone, put your variables, and run. And this is the definition of the sandbox, which is made by the policies that we are delivering into the AWS account. All right, time to Terraform init. Then plan. And finally, so during the planning, we are seeing that we are delivering 22 resources, that are the needed resources to finally make our workspaces. Then, with a single command, we are creating workspaces and all the roles and also the policies. So as you can see, we have 3 workspaces according with the definitions that we put in our TF vars. As you can see, no password will be shared. There are no passwords, for sure. And also, we have the roles. And by the roles, we have the sandbox and also the identity or IDC definition as a trust relationship. OK, just let's back to the presentation. All right. So this is the first part of our quest behind the secret management, especially when we are authenticating and do a sandbox where you can put our deployed infrastructure element, but also the application. Then there are the second part of the problem, which is handle the secret during runtime secrets during our deployment, because as we've seen before, we have some secrets that are generating during runtime, during our infrastructure deployment. And so, first off, we use the sensitive option in Terraform Vault to define the first element we need for the Terraform template to be connected with the HashiCorp Cloud Platform. And by using the synchronization, which is the Vault secret feature that can be used to synchronize things that are placed on HashiCorp Vault secret to HashiCorp Cloud Terraform Cloud, we simply manage the things that are creating from HashiCorp Vault secret to Terraform. Then we using Terraform provider, using these two Terraform providers, which is HashiCorp Cloud Platform and Vault secret, we can manage back the secret, and also we handle the creation of the secret. So it's time to see things mechanically how it works. And let's put, so as we've seen before, we must define the first secret. Then we have the workspace which is defined during our first deployment, as we call Bootstrap. And then using synchronization, the secrets are available as a variable sets. Then, after infrastructure templates will be delivered, we have new secrets available in the same app. And then we can use the secrets, for example, in a second workspace, and for example, when it's time to deliver our application. OK, let's see how it works. Back to the demo, again, for the last time. So, as we see here, as you see, we have a pre-definition, and the most important thing I want to highlight is the presence of the EC2 key here, which is an empty key, a slot that we can use during our infrastructure deployment. Then we see that using synchronization, we are synchronizing all the secrets as a variable set in Terraform. And then it's time first to create an EC2 instance. This is let me say, a dummy example, but it's just to show you how to create an EC2 instance and an EC2 key. Then we are populating this EC2 key with the values that came from the EC2 creation during the infrastructure deployment. Then it's time to deliver our application. Again, this is a dummy example, but just to see that we are simply doing a hello application 1 in our EC2 instance using Nginx. Then, after installation and using the remote execution, you will find, opening the address, that you have the word secret. So, no secret, so back to the presentation, no secret is shared. So, we are concluding our presentation. It's time to wrap up. So, we have seen that using OIDC authentication, we have a dynamic way to handle and improve asset security, right? Then we have found a way, because we are using a platform, to centralize templates, but also centralize the way we are handling the credentials, which are, that are new credentials or credentials that are coming from our deployment. We can redistribute this across the environment, and most important thing, we can control which environment they can use this credential, right? And then using HashiCorp Vault secret, we have a really great synchronization of the values of the secrets that are creating in HashiCorp Vault to Terraform. But we can use HashiCorp Platform Terraform provider to manage the secret back. You can test by yourself. These are the links. And most important things, stay in contact, stay connected, and give me your impression, or just use it and try to push your new commits in my Git repo. And before leaving this presentation, I want to share with you my infrastructure as code 10 commandments. So for today, we respect the 4th commandment and also the least privileges with the 6th and the 8th. So just print this, put it on your wall, especially when you are dealing with your developers, and you will be fine. And just repeat from 1. Thank you very much. Thanks a lot. Grazie.